question 4 wants us to consider this curve. The first part wants us to state the coordinates of any points of intersection with the axes. So we look at part 1 first. Now for our y-intercept, we have to have x equal to 0. What does that give us? That means y is equal to 0 squared plus 3 times 0 over 0 take 1, which is equal to 0 in itself. So therefore we know our y-intercept is at 0, 0. Now this is also going to be one of our x-intercepts. So what's the condition for the x-intercept, or intercepts? The condition is that y is equal to 0, which gives us 0 is equal to x squared plus 3x over x take 1. So if we factorize and bring that up the other side, we get 0 is equal to x minus plus 3. So that means x equals to 0, or what am I doing? Or x equals to negative 3. So this one we know already. This is the new one. So we can say therefore x-intercepts at 0, 0 and negative 3, 0. So that's the first part. So we can erase this now. What should we do for part 2? Part 2 wants us to find the equations of the asymptotes. So the first one's pretty straightforward. We know that this whole thing is undefined when the bottom line is equal to 0. So we say x take 1 equals to 0, which means that x equals to 1 is an asymptote. And if we wanted to be precise about it, we could even say that this is a vertical asymptote. What's the other one? Well, for the other one, we need to actually do some long division to simplify this expression. So we're going to divide x squared plus 3x plus 0 by x take 1. Now my way of long division is it looks a little bit different, but it's basically the same. Instead of putting the numbers up here, I put them down the side. So the first thing I'm going to multiply this to get it the same as the first term is x. So now x times x becomes x squared minus 1 times x. I'm going to subtract the whole thing away there. And I then get 4x plus 0. Now, to get the 4 the same as this, 4x the same as this x, I'm going to multiply by 4. So I get minus 4x minus 4. And that leaves me with a remainder of 4. So I can say y equals to x squared plus 3x over x take 1 is actually equal to x from here plus 4 from here plus 4 over our original expression, x take 1. Now, as x tends towards infinity, in the positive or negative direction, what happens here? This term, the bottom line, starts becoming very large in magnitude. Much larger, in fact, than the top line. So this thing tends towards 0. So what can we say about the expression as a whole? We can say that y tends towards x plus 4. So therefore, y equals to x plus 4 is a oblique asymptote. third part is slightly new, and this is where it's going to get slightly tricky. So we'll just tidy this up again. Part 3. We're asked to show that this expression cannot lie between y equals to 1 and y equals to 9. Basically, we're asked to show that 1 less than x squared plus 3x over x take 1 is less than 9. We're asked to show that this whole thing is impossible. Okay? So how do we go about doing that? Well, first thing we're going to do, what is the conditions under which this expression can lie above 1? When can this happen? Now, you know with an inequality we can't just multiply up to the other side, because this term here could be negative. So what do we have to do? We say 0 is less than x squared plus 3x over x take 1 minus 1. So this simplifies and we get x squared plus 3x take x take 1 all over x take 1. So we've just brought this to be the same denominator. So this is 0 is less than x squared plus 2x plus 1 over x take 1. So 0 is smaller than, and if you factorize this top line, you find that it's actually x plus 1 squared over x take 1. Now, where is this whole thing bigger than 0? Or when is it positive? This number here is always bigger than or equal to 0. So this it's never going to be negative because of this one. What might happen? Well, this one could be negative, or this one could be positive. If this one is positive, the condition is met. If this one is negative, the condition is not met. So really, this whole thing is only true if x take 1 is bigger than 0. If it's smaller than 0, then because this is positive, this whole thing will become negative. So it can only work if this term x take 1 is bigger than 0, or if x is bigger than 1. So if x is bigger than 1, then we know for sure that this y is going to be also bigger than 1. But that was only half the story, right? What was the other half? The other half is to show that it cannot be beyond 9. It cannot be less than 9. So at the same time. At the same time is important, right? So we're looking at 9 is bigger than our expression x squared plus 3x over x take 1. And we go through a very similar set of steps. And here we notice that this top line here is actually x take away 3 squared over x take 1. So again, using a similar line of logic, when is this whole expression negative? Well, this expression is negative. This top line is always positive. So for this whole expression to be negative, the bottom line, the denominator, needs to be negative. So you need to have x take 1 being less than 0 or x less than 1. So that means it's impossible for these numbers it's impossible for y to be between 1 and 9, because if y is bigger than 1, then x is smaller than 0, and if y is less than 9, then x is less than 1. so that those two things cannot happen at the same time. Therefore, we can safely say that y does not lie between 1 and 9. Part 4 of this exercise we will do in class.